morning one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today our topic is Geosynthetics for Slope Stabilization. So this case study, what are the various parameters involved for getting the slope stabilization using this geosynthetics. So we have a different number of techniques for getting the stabilization. In particular case study, why we choose geosynthetics? What are the parameters involved in that? What are the various concerns are there? What are the various practical challenges? What are their solutions? How we will get the solution? How the process involved in these geosynthetics for getting the desired properties of the project requirement as per the construction requirement, we will see in this particular class. Introduction to geosynthetics in civil engineering. As a civil engineer, synthetics are nothing but geosynthetics are the synthetic products which are used in civil engineering to improve the properties of the soil. To improve the properties of soil, or soil properties are going to modify using this kind of geosynthetics. So they include geotextiles, geogrids, geomembranes and geocomposites. So in this, the importance of these geosynthetics play a crucial role in ground improvement techniques, particularly in stabilization in the soils. So for getting any kind of project construction, we required some modifications. So in the site demands few ground improvement parameters. They need improvements for getting that construction work done. So in that, the stabilization of soil is one of the parameter. Stabilization of soils may required in some of the conditions. Otherwise, reinforcement is required. Reinforcing is may required, and control of erosion is also required in some of the scenarios for getting the construction work done. In various characteristics are involved. So in those scenarios, we may choose geosynthetics as a technique, one of the ground improvement techniques. It plays a role in these kind of scenarios. Here we have to understand what kind of reinforcement, force and controlling erosion is there. These are the parameters we have to understand. So here these geosynthetics are the improvement for getting the desired properties of the project requirement. In any project required these kind of solutions. As a ground improvement or ground modification point of view, we may choose this geosynthetics. So this is the overall view about these geosynthetics. So they are coming from the synthetic material. In this overall project overview, in this particular case study, Bangalore-Mysore Infrastructure Corridor. Bangalore-Mysore Infrastructure Corridor. So here the Bangalore-Mysore Infrastructure Corridor is a major highway project connecting two important cities in Karnataka in India. So it connecting Bangalore and Mysore. These are the two important cities in Karnataka in India. So the project faced significant challenges due to the region's topography, including unstable slope prone to landslides. So this is the major challenges which we are going to understand in this particular project. So in this is the highway project connecting two cities in that particular region, unstable slopes and lead to the landslides. Here the geotechnical challenges, the highway alignment pass through hilly terrain. So it passes through hilly terrain. It passes hilly terrain. It may lead to the landslides. So the proper ground improvement techniques modifications are required for construction of these, which were susceptible to landslides. Not only landslides, soil erosion and instability. It depends upon the season. So like that we have to understand this is the significance of this project. So in this scenario, these are the challenges are there in this particular project. So what kind of techniques we are using? So here we introduce slope stabilization. So because of the, what are the constraints are there for this project, highway project? So these are based on the hilly region, we are facing these challenges now. As a ground improvement techniques, we have to introduce this term, that is slope stabilization. This slope stability refers to ability of a slope to withstand movement or failure. So it is influenced by the what type of soil, soil type and angle, moisture content, and also the external loads These are the things which are involved in this particular case. So these are this already involved in this type. So now slope stability refers to the ability of slope to withstand movement or failure. It is influenced by the factors such as soil type, slope angle, moisture content and external loads. In these landslides, soil creep and erosion are common forms of a slope failure that can compromise the safety and functionality of a infrastructure. Here, the need for stabilization, slope stabilization is necessary to prevent landslides, reduce erosion and ensure the long-term stability of slopes adjacent to infrastructure like highways. So, for this purpose, we need the stabilization. Slope stability, what are the common slope failures? Those are landslides, soil creep, erosion are the common forms of slope failure that can compromise the safety and functionality of the infrastructure. So, we introduce this slope stabilization. What is the role of geosynthetics in slope stabilization? We have different types of geosynthetics. Those are geotextiles, geogrids, geomembranes and geocomposites are the types which are involved in these geosynthetics which we used. In geotextiles, permeable fabrics that allow water to pass through while preventing soil particles from moving. So, those kind of fabric which are soil particles where from moving, the prevention of the soil particles from moving, such is known as geotextiles. These are permeable fabrics that allow water to pass through. These kind, they are allowed to water pass through while preventing soil particles from moving. They are used for drainage and erosion control. So these kind of geotextile we use it for erosion control and drainage. Now, geogrids, grid-like structures that reinforce soil by providing tensile strength, reducing the potential for soil movement. Here, these geogrids are reducing the soil movement. Reinforce soil by providing the tensile strength. Reinforce. So that is nothing but geogrids. These are grid-like structures. That why we are calling them as geogrids. Now, geomembranes. These are geotextiles are permeable fabrics. These are impermeable membranes used to prevent water infiltration through, less common in slope stabilization. They are relevant for other applications. So these are permeable, these are impermeable membranes, geomembranes used to prevent water filtration through, though less common in slope stabilization. They are relevant for other applications. Geocomposites. Combinations of geotextiles, geogrids and or geomembranes tailored for specific applications such as drainage and reinforcement. Such type we may choose these geocomposites. These are the various types and their role in geosynthetics. So, as per the requirement of the project, we choose which type is suitable for the particular stabilization, slope stabilization. In this mechanism, reinforcement, separation, drainage, erosion control. So, in these mechanisms of action, what kind of mechanism is going to happen for preventing those relevant conditions. Here, these reinforcement geogrids provide tensile strength to soil. So, it means whenever the geogrids provide tensile strength to the soil, it means preventing movement and enhancing the soil stability. It affects the what kind of property. So, in this reinforcement, it means nothing but the tensile strength and preventing the movement and enhancing the slope stability. Prevent and enhance. In separation, geotextiles separate different soil layers. So, what kind of soil layer they are going to separate those soil layers, preventing contamination and maintain the integrity of the stabilized slope. In drainage, these geotextiles and geocomposites facilitate the removal of excess water. They are going to remove the excess water, reducing the pore water pressure, and it leads to preventing the slope failure. In erosion control, geotextiles cover the soil surface, preventing soil particles from being washed away by the surface runoff. These are the mechanisms which are involved in this particular geosynthetics. So, reinforcement, separation, drainage, erosion control. Involved in this slope stability. Various mechanisms which are involved. The detailed process of geosynthetics application in this particular condition corridor highway, considering this is highway corridor and the region is in hilly region. The challenges are stability, erosion, landslides. The soil assessment, comprehensive geotechnical surveys were conducted to assess soil properties, slope angles and hydrological conditions. This soil assessment, those comprehensive geotechnical surveys were conducted to assess soil properties, slope angles and hydrological conditions. These design criteria, the design considered factors such as the height of the slope, how much height of the slope, soil type, height of the slope, load, how much load, what are the various environmental considerations. The choice of geosynthetics was based on these criteria. So, in this, after the site preparation, installation of geogrids. Selection of geogrids were based on the required tensile strength, size and durability. The material needed to withstand the specific loads expected on the slope. The placement, excavation, layering, anchoring. And in this excavation, the slope was excavated in layers to allow for the placement of geogrids. In layering, geogrids were placed in horizontal layers within the slope, compacted over each layer to ensure firm contact between the soil and the geogrid. Anchoring, geogrids were anchored at the slope face to prevent them from sliding out of the place. As a compaction parameter, each soil layer was compacted to achieve the desired density, ensuring the geogrid provided effective reinforcement. So like this we are going to installation these. In use of geotextiles for drainage and erosion control, the selection of geotextiles were chosen for their permeability and strength. They needed to allow water to drain while holding soil particles in place. In this installation, drainage layers, erosion control. So as a part of drainage layers, geotextiles were placed behind retaining walls and along this slope to facilitate drainage, reducing pore water pressure. And erosion control, geotextiles were laid on the slope surface and covered with a protective layer of vegetation or riprap to prevent soil erosion. In this vegetative cover, in some areas, geotextiles were combined with hydroseeding to promote vegetation growth, further stabilizing the slope and reducing surface erosion. This vegetation cover is also plays a vital role in reducing the erosion. And this vegetation growth in some areas, so it reducing the effects of the surface erosion. So these kind of uses of geotextiles, so this is this protected the layers and reducing the effects of those kind of erosion effects and landslides. These are reducing. So this is major use of these geotextiles for drainage and erosion control. In monitoring and performance evaluation, in short-term monitoring, visual inspection, initial performance. In short-term monitoring, visual inspections, regular inspections were conducted during and immediately after installation to ensure correct placements of geosynthetics and the effectiveness of compaction process. In initial performance, the slopes were monitored for any signs of movement or erosion, especially during the first monsoon following construction. In long-term monitoring, instrumentation, performatrix, maintenance. So those instruments as inclinometers and piezometers were installed to monitor slope movement and pore water pressure over the time. The performance metrics, the effectiveness of the geosynthetics was evaluated based on the slope stability, reduction in erosion, erosion reduction, and no landslides, absence of landslides. Absence of landslides. So these are the performance metrics. So the effectiveness of geosynthetics, this monitoring is in long-term parameter. And also the maintenance, periodic maintenance including checking the condition of geosynthetics and repairing any damage caused by environmental factors. In environmental and sustainability considerations, in this environmental impact, minimized soil disturbance, sustainable materials, vegetation promotion. The use of geosynthetics reduced the need for extensive earthworks, minimizing the environmental disruption. In sustainable materials, geosynthetics are often made from recycled materials. So that's why those are sustainable. They are recycled materials and are designed to last for decades, reducing the need for frequent replacement. So environmental impact is already reduced in this particular, we are using this kind of material. This vegetation promotion, by supporting vegetation growth, geotextiles contributed to the ecological stability of the slope, enhancing the habitat and reducing the carbon footprint of the project. So these are the considerations which we are going to understand in this particular environmental and sustainability consideration. The long-term sustainability, durability, reduced maintenance. Geosynthetics are designed to withstand harsh environmental conditions, ensuring the long-term stability of this slope because of the hilly regions and chance of landslides and erosion. These are the harsh environmental conditions for this particular case study. So in this reduced maintenance, the reinforced slopes required less maintenance over the time, resulting in cost savings and reduced in environmental impact. Coming to the comparative analysis with traditional slope stabilization methods. In these traditional methods, retaining walls, tracing, drainage system are there. So here those traditional methods like retaining walls were considered but were more expansive and less flexible than geosynthetics. So these are the traditional methods we have. Those are retaining walls. It is a huge structure. For this, it required so much of strength, manpower, equipment, etc. These are all required for this environmental. It is also expensive when compared to, and there is less flexible. And environmental, it's more impact. Why? Because there is no chance of creating, getting vegetation, revegetation, and reducing the other things. It's difficult, but it is more strength. It has their own kind of advantages when compared to the geosynthetics. We are going to understand. The tracing the slopes was another option, but it required more land and was less effective in long term. In drainage system, traditional drainage system could not provide the same level of integrated erosion control and reinforcement geosynthetics. In these advantages of geosynthetics, cost effectiveness, flexibility, integration. In this, geosynthetics offered more economical solution when compared to the other traditional with lower material and installation cost. In this, the flexibility, the geosynthetics can be tailored to specific site conditions, make them more adaptable than rigid structures like retaining walls. This integration, geosynthetics provide a multifunctional solution combining reinforcement, drainage, erosion control in one system. These are the advantages. So overall, the geosynthetics in this particular Bangalore-Mysore infrastructure corridor successfully stabilized the slope, preventing landslides and reducing erosion. The project demonstrated the effectiveness of geosynthetics in challenging geotechnical conditions. So here, this case study highlights the importance of site-specific design in geosynthetics applications, careful considerations and sustainable factors. So in this, what kind of geographical and geotextile content? In this, where it is located, what are the terrain characteristics are involved? Already these soil compositions, how the slope stability concerns, how this project significance based on the traffic and economical importance, various topographical challenges, what kind of erosion we are going to change. Using all these things, using these geosynthetics, what are the regularities? So these are the challenges we are going to understand in this particular case study. Thank you. We will see in next class.
Like, share and subscribe. Hit the bell icon for more updates.